A video up for number 13, and this one's fairly similar as well. So here's here's the one that you had, and I'm going to do it a little bit different than I did in the video. It kind of depends on what the exponents are, which way I would go, but there's plenty of ways to do this, so here's a couple of them. So we start off with these 2 points, and we know we're trying to write an exponential equation, so it's going to take the form y equals ab to the x. And what I have here is an x and a y in each of these ordered pairs, right? It's an x and a y. And so I have 2 points, and I have 2 unknowns in a and b. So what that means is I can write 2 equations using these x's and y's, and then figure out a way to combine them and solve for each of those unknowns, which are the a and the b, the coefficient and the base. So for this one, I plug in the 5/3 for the y side and the -1 for the exponent. Same thing over here. 45 is the output, so I got that on the y side, and the 2 is the exponent, it's the x. And then I looked at these 2 equations and just kind of tried to figure out what's the path of least resistance for getting this solved. And I could solve for, there are 4 variables, so there's at least 4 ways I could do this, and even more once I actually start solving. So there isn't anything particular about this one I'm doing, it's just kind of what I picked this time. And again, it's a little bit different than what I did in the video, but that's because there's a lot of ways to do it. So anyhow, this b to the -1, remember when you have a negative exponent, that means you can move it down to the denominator and then write that as a positive exponent. So that's what I did here to get rid of that -1. And that gave me where I could kind of get at the a and the b, whichever one I chose. And so the easiest thing to isolate was the a over here, so I multiplied both sides by b, and that's how I got this 5/3 b equals a. On this side, I could have also divided over the b squared. I actually started to do that initially, and then looked at it and went, oh, that's going to make like fractions and fractions, which seemed harder. So that's why I did what I did here. But once I have a is 5/3 b, then I can take this expression and plug it in for that a right there. And that got me to right here. And so now I have one equation. I took the 2 equations and rewrote them as one equation in a single variable. And from there I can clean it up and solve. So I did b times b squared for b cubed. And then there was this 5/3 out front. I want to isolate the variables. I multiply both sides by 3/5 to get rid of that fraction. You can also multiply by 3, divide by 5, same exact thing. And that went in 9 times 3, so I got the 27. And then b cubed is 27, and then I didn't write what I did, but I cube rooted both sides of that, and then cube root of 27 gave me 3. So that gave me my first variable, and then I can plug that into either of these equations, and right there seemed the easiest place to do it, so I plugged in the 3 right there for the b, and then was able to cancel the 3's and got the a as 5. And then just rewrote it with my a is 5 and my b is 3. And so they all kind of take that form. And again, which way is the easiest? The solving is a little, you can go down a harder road or an easier road. There's lots of right ways to do it. So just kind of trying to spot which is the one with the least amount of suffering. And like I said, I initially tried to do this by isolating that a, and went, that's going to give me like 45 over b squared over b, and I thought that would be confusing, so that's why I kind of backtracked and tried a different variable, and it was easier. So that would be my advice, is to go, there's more than one way, so to try to spot the easiest one. Hopefully that helps. Holler if you still got questions.